Okay, Lagrange multipliers. So this is just a couple examples of using this technique, which is essentially the gradient f equals lambda times gradient g, and you mess around with this idea. And you have two different functions and all that, g of x and f of x, and g of x is sort of where you're having stuff. It works for problems. So I'll just go over 4 examples. We're just going to focus on two-dimensional here. So find the points on the ellipse 2x squared plus 2y squared equals 1, where f of xy equals xy has its extreme values. So f of xy obviously equals xy, and g of xy will equal x squared plus 2y squared minus 1 equals 0, because we need it equals 0, so we just subtract that from it, the 1. So that's how it works. It's basically what it's on is g, you know what the function is on, and then the other function is sometimes explicitly given like this, but not always. So we set this up, and we really quickly, del f is the gradients aren't going to be done in detail, like you understand out again by now. Xy is the gradient. You need to find the gradient of that, so it's y and x, yi plus xj. Because with respect to x, it'll be y, and with respect to y, derivative will be x. And 2x and 4y will be the derivatives for g. So, in the end, you just compare them. Y is I here, and 2 lambda x, and you multiply lambda n, 2 lambda x I. So y equals 2 lambda x, and x equals 4 lambda y. And you can do it. I mean, you basically have to solve a lot of little linear equations in these problems. Again. And I'll show you at the end. The last example will have one where I show like how this can get out of hand, and you have to sometimes revise your method if it seems to be not working out, which I did. I guess I try to keep it consistent, but it's not always the easiest, these methods. So we have x given as 4 lambda y, and we plug that in this case, y equals 2 lambda times 4 lambda y. So y is equal to 8 lambda squared y, which implies that 8 lambda squared equals 1, and we're solving for lambda here. And there's a reason for that. We solve for lambda and eventually get plus or minus 1 divided by 2 square root of 2. And we have that plus or minus 1 divided by 2 square root of 2. And we have x equals 4 lambda y, so we'll plug that in. And we'll get it so that x equals plus or minus 2 divided by square root of 2 times y. So 2, it could be, and I simplified down to just y, x equals plus or minus square root of 2y. Then we plug that x value, since we have it in terms of x and y, we could solve for both variables now by plugging into g. And you usually do end up plugging into g to find your final values a lot of times, because that's kind of a constraint in this case. So plus or minus square root of 2y squared plus 2y. Yeah. You eventually solve it for y and get plus or minus 1 half. That means x equals plus or minus square root of 2 times plus or minus 1 half. And I guess because they're both plus or minus, this will be plus or minus 1 divided by square root of 2, and then because it'll be square root of 2 over 2, and you can simplify that down just 1 over square root of 2, which is how a lot of sources would want it for some reason this form, but it just depends. It works for you. And the extreme values are at plus or minus 1 over square root of 2, negative 1 half, and same x value but y value being positive. And I guess this works because of how the setup is. Y and x, there's a lot of things. I suppose you could list them all out, but I think there's a better example of this in the next one for Lagrange multipliers. Yeah. This one only takes 1 page. So find the maximum value of f of xy equals 49 minus x squared minus y squared on the line x plus 3y equals 10. So f of xy is given, obviously, and g of x will be this. It's what it's on the line, so that's also the hint, g of x. So you subtract 10 and get equal to 0. The gradient of f is just I plus 3j. Oh no, that's g, I plus 3j. X plus 3y minus 10 will just be... f is negative 2xi minus 2yj. That should be expected. Then you multiply in the lambda to that, so it becomes negative 2x I minus 2yj equals lambda I plus 3 lambda j. This one is pretty short because it's obvious. Negative 2x equals lambda and negative 2y equals 3 lambda. So just lambda equals negative 2x. That's what I went with. I mean, there's other ways, I think. But let's go with this. And this seemed to work out relatively quick as well. There's other methods would, I think. So negative 2y equals 3 times negative 2x. And you get in terms of x, so x equals 1/3 y. You plug this into g, function g. 1/3 y plus 3y minus 10. You get equals 0, and 10/3 y equals 10. So that implies that y equals 3 if you do division. 10 divided by 10/3, you divide by that on each side. Then you plug into x equals 1/3 y 3, and then you get 1. So at that f of 1, 3 is your maximum value, and you plug in, you get 49 minus 1 minus 9, which equals 39. So maximum value is 39. If you want to find the maximum value, you get it. Find the points on the curve xy squared equals 54 nearest the origin. So distance from origin is the square root of x squared plus y squared, because the origin is points 0 and 0 you're moving away from. So the minimum is where x squared plus y squared equals 0, and that's how the explanation will go. So f of xy equals x squared plus y squared in this case. And g of xy is the function given. That's set up, and then you do the gradients again. G will just be y squared I for x, and then 2xy for j. 2xi plus 2y will be gradient of f. And you get 2x equals y squared lambda when you do the plug-in. And that means that, I mean, I just picked that one. I mean, I guess you could have used also. But no, I did. So 2y equals 2x y lambda as well from that, from the j. So 2y equals 2xy lambda implies that lambda equals 2y over 2xy. Solving for lambda in this case, I get lambda equals 1x, 1 over x. So 2x equals y squared times 1 over x when we plug into the other one, to this function over here. 2x equals y squared lambda. Because we want to get it in terms of x and y, so we can plug in the g, basically, the g function. You solve it and get y equals plus or minus square root of 2x times x. Because it's square root of 2x squared, and then I can plot the x. And this won't matter because it's too much, because we're going to square. So we square it, and we get, it's x times that squared minus 54, so you eventually get x times 2 times x squared equals 54. 2x cubed equals 54, x cubed equals 27, so x equals 3. So x equals 3 implies that y equals plus or minus 3 square root of 2. Plug it in, that's redo it. So the points 3 plus or minus 3 square root of 2 are the points on the curve xy squared minus equals 54 nearest the origin. It's 2 points. So it's the positive and negative variant of y, but x stays the same. Find the maximum minimum values of x squared plus y squared subject to the constraint x squared minus 2x plus y squared minus 4y equals 0. This one takes some work to figure out what to do. So I set them up, and then I take my gradients. The g is not going to be as easy though this time. So you can see we go through the process here. 2x equals 2x minus 2 lambda, and 2y equals 2y minus 4 lambda. You can distribute it, I don't think that'd be, but I do try to do this solving with all of them in terms of lambda and plugging into g, which is a method sometimes, I guess. Because you can plug them into g into all lambdas, and you get a value for lambda. So you can plug those back into x and y, which is sometimes recommended for some of these. Like the last one, I think one of the recommended solutions do it that way. But this is not going to work out easily. So let's try another method. So lambda would be carried out and get rid of this way. So we eliminate lambda and have this in terms of x and y, and we can solve for x or y in terms of the other. And you call this process, we basically are dividing the two equations here, two relationships. Then we simplify from there by we cross multiply Eventually we get it simplified down to negative 8x equals negative 4y, so y equals negative 8x divided by negative 4, which equals 2x. So y equals 2x. Plug into g and you get a value of x for that. So 5x times x minus 2 equals 0 in the end. Then x equals 0, x minus 2 equals 0, so x equals 2 in that case. X equals 0 means y equals 2 times 0, which equals 0, and x equals 2 means y equals 4. So 0, 0, and 2, 4 are the points. And you plug in to get these values, 0 and 20. So maximum value at 20 and minimum value at 0. I mean, those are either one of them's a minimum, one's a maximum, so you can just plug in to figure it out. You don't have to do anything crazy because these are the only 2 points that would work. So one's a max, one's a minimum. Do the highest as the max, lowest as the min. Well, I think that's enough for Lagrange multipliers.